Hello all, welcome to another LeetCode problem. So today we are going to solve LeetCode number 40450, delete a node in a BST. So in a given BST, we are given a key value that we want to delete from particular tree. So key is basically one of the node in the binary tree, and then we want to delete that node and then return the remaining binary tree. But one thing is to remember, this is a BST, so we want to make sure that the BST properties are maintained. So everything on the left, basically on the root node, everything on the left is small, then everything on the right is greater than the root node. So in this example, so here the 3 is getting deleted. So from this particular BST, we want to delete 3 and then return the remaining tree from here. So let's see how we can solve this problem. So in this, if we read this, so it is given that there are 2 steps. So one step is to find the node, and then second step is a delete the node, right? So let's try to understand how we can solve this problem. So as it's mentioned that first step is to find the node. For example, let's say this is a one BST I have, and then let's say I want to delete a node called, let's say 30, right? So let's say my key is 30 and I want to delete this particular node. Now in the given tree, I have to do a search first. I have to go either on the left side and then on the right side, and then I keep searching wherever until I find my key node, basically your root.val, right? Root.val. Once I find this is equal to key, that's the node I want to delete it. Now deleting means I just don't want to delete entire particular subtree. I just want to delete a particular node and then return this remaining subtree into the, I've attached the remaining subtree to the parent node. But let's say if I'm deleting 30th, so I'll attach the remaining subtree to 50th node, and then I will return the entire tree, right? So how do we solve this thing? So there are basically four test cases, or four cases we can encounter when we are working with the tree, right? So let's say I'm deleting a node which doesn't have any child. So case one is I'm deleting a node which doesn't have any child. There is no left child and there is no right child, right? Only, let's say this one, right, or leaf node, there is no further child available. So in this case, let's say I'm deleting 73 here, so there is no left and there is no right. So I'll just return empty. So I want to make sure this node becomes null, right? So I'll just return empty. So the left child of 80 becomes none, and the right child only remains as it is, right? So that's the one case number one. Now another case, let's say I want to delete a tree. Let's say I want to delete a particular node which only has, let's say, one child. In this case, this is case 2, either left child or it could also have the right child. So in this case, let's say I want to delete this particular node, so I'll return the remaining node to the parent. Let's say the parent is 5, so I'll return the second node to the fifth, so that this node goes away. Only left, this is the root.left will be returned. So I'll just remove this. Only I'll return the this particular node, so that can be attached to the parent node. Similar case, if only let's say right child is there, then same thing I'll do. Let's say 2 is here. I'll just remove this one. Basically this is not a valid tree. Let's say this is 7 or something, because it said this has to be greater, right? And this is less than 10. So in this case, let's say I want to delete this particular node again, node number 4. The remaining part is this one. There is no left child, so I don't want to worry about it. So only I need to worry about the right child. So when I am returning, I'll say, okay, take this right child and assign it to the parent node. Just forget about this particular node. Now challenging part comes when a node has both the child. Then which one to return, right? Let's say node has 4 has left child also and the right child also. then how do I return to the parent node? Then that becomes a challenge. So now in order to solve this problem, we'll see how we can fix this. So think of a binary tree, right? So when we want to write a binary tree as an in order traversal, so we always write it like a 2 4, let's say for example 2 4 7 and then 10, right? So whenever I'm replacing this node, I want to make sure that the BST properties are maintained, right? So in this case, next element for the 4 is 7. So I'll replace the fourth node with the seventh node, and then I'll just remove this particular seventh node from the binary tree. Now, how we can do that? Let's say in this coming back to a previous example, right? So let's say I want to delete 30. Now in this case, it has both the child, left child also as well as right child. Now I want to delete this particular node, right? So I have to replace 30th with the one of the node from the right child. Now if I think of an order traversal, next node, possible node for 30th will be 31, right? So what I'll have to do is I'll have to go to the right child and then traverse to the left and then pick up the leftmost element and then assign it to the 31, because keeping in mind that my in order traversal will be, let's say for this one, 23. So left root and right, left root and right, so 11 23 25 and then again 30th, again it will come here, so 31, right? So next possible node is 31 for 30th. So when I want to replace 30 and keeping BST property intact, so I'll have to replace with the 31st node here. So in order to search the 31st node, I'll have to go to the right side, and then right side I'll have to go to the leftmost element in the tree and then use the tree as a node here. So this 30 will become 31. So 30 is going to be your 31, and then this 31 will be deleted. So what is remaining is your 31, 35 and 42. So 31, 35 is greater than 31, so your BST property is maintained, and then 42 is greater than 35, so again your BST property is maintained, right? So this is only a complex case when you want to delete something, when a particular node has both the child. Otherwise, we when just have one child, then it is simply return the child to the parent. So that will be easy case. So let's see how we can solve this problem. So let's go back to the editor. So as I mentioned, so we have to deal with the 4 cases. First case where it has they're both childs are null. So basically, if your root dot left is none and your root dot right is also none, right? Then we have to just return none because there is nothing to be assigned. Second case is when you only have one child. This is, let's say you only have left child, so you have to check if root dot left is available and root dot right is none, right? Then you have to return only root dot left because that's the only child available, right? Third case is when you only have the right child, you don't have left child. If root dot right is available and root dot left is none, then you have to return root dot right. Now last case is if you have both the nodes, right? So you have root dot left as well and root dot left. That's the last case as well as root dot right. So now as I mentioned, when we have both the child, so I'll have to go to the leftmost node, which is here, and then return this node as a assign this node as a tree and then delete this particular node, because now this 31 is assigned here, right, in place of 30, so I have to delete it. So how we can do that? So we have to traverse first, so we have to traverse on the left hand side. So we go to the cell left, we assign a temp element and we say while temp dot left is available, you keep traversing to the left side. So temp equal to tmp dot left. Now I reach to the leftmost node. Now I'll say root dot val equals to tmp.val. I'll assign the same in this case 31. I'll assign to 30 now. Now I'll have to delete 31 as well, right? So in order to delete that, I'll just say self dot delete node, and I'll travel to the root dot right, and what value I want to delete? This one, right? 31. Oh, sorry, tmp.val. Alright, let's see if I put this pop. So that's the 4 case, and the remaining code is basically we are searching for the key. So if somewhere I find the match key, I execute one of these 4 test cases, and then I delete a node. So if I try to run it, okay, all the test cases goes well. Now you can go ahead and submit. Hopefully it works. So that's the algorithm. So only what we need to remember, okay, something goes wrong here. Let me check again. I have to return it actually. I didn't return. Yeah, this works fine. Uh, yeah, thank you for watching video. Hope you like it. Bye.